In this example, we have a question that involves using a straight line and a quadratic. We are told y is equal to 2x, our straight line, y equals to 8 minus x squared. For x greater than 0, we need to find the points of intersection. There are 2 points of intersection between the parabola and a straight line, but we're told we need to find the one where x is bigger than 0. So for part A, we want to find when the two graphs equal each other, that is, when 2x is equal to 8 minus x squared. Taking everything to one side of the equation, we get x squared plus 2x minus 8 equals 0. We can now factorize that. Factorizing it will give us x plus 4, x minus 2, equals 0. Solving, x would equal negative 4, or x will equal 2. We're going to reject x equals negative 4 because we were told x has to be bigger than 0. The question asked us for the points of intersection, so we need to find the coordinates. We know when x is equal to 2, y will equal 2 times 2, which is 4. So the point we require is the point 2, 4. That has been represented on our graph. Part B of the question says to us, sketch the region bounded by the two curves. So obviously I have put in the graph already. In there, you can see that we have y equals 2x, and you can see that we have y equals 8 minus x squared. So I'm just going to write C graph. That brings us to part C of the question. Represent the area A of this region by an expression of the form. Now, if you have a look at it, the expression has functions of y. What we have is functions of x. So it doesn't matter which one I call fy and which one I call gy. So here we go. I'm going to say we've got y equals 2x. X then would we equal y divided by 2. Just because fy is the first one there, I'm going to write fy, a function of y is y on 2. The next thing I'm going to do, I've got y equals 8 minus x squared. I need to get this as a function of y. So, rearranging, I have x squared equals 8 minus y, which would give me x is equal to plus or minus the square root of 8 minus y. We are only going to be interested, though, in the positive half. So x will equal for us positive square root of 8 minus y, because we want the positive half, which you can see quite plainly from the graph along here. That will be my gy. So gy equals the square root of 8 minus y. Now, it says represent the area A of this region by an expression of that form. So the first things I know, and I'm going to use red for the first integral. I've got an integral from A to B. The first bit is the straight line. I'm doing this in terms of y, so I'm going from y equals 0 to y equals 4. So my area is equal to the integral from 0 to 4. Fy I called y on 2 dy plus, now I have to look at my second integral, which I've circled in blue. This is the curved part. This is going from the 4 all the way up to the 8. So it is the integral from 4 to 8 of the square root of 8 minus y dy. So the little a was equal to 0, the little b was equal to 4, the little c was equal to 8. We have said Fy is y on 2. We've said gy is the square root of 8 minus y. Now we have to evaluate our integral. Area, anti-differentiating y on 2, I get y squared on 4 between 0 and 4, plus anti-differentiating, now remember, the square root of 8 minus y is 8 minus y to the half. So using your rules for anti-differentiation, that will give us minus 2/3 times 8 minus y, 3 on 2, between 4 and 8. Substituting in, we will get 28 on 3 square units.